All right, and so we want to have our perfect squares there handy. If you want to just reference the board there, since I have the perfect squares from 1 to 20 or from 1 to 400 written up on the board, we can use that. Okay, and you're going to want to have having a calculator handy. If you have one on your phone or something like that, that might not be a bad idea to have that out too. Okay. Okay. So let's just kind of jump into things here. So let's say our question is something like this. What is the square root of 50 equal to? It's not necessarily good English there, but we'll start with that. Okay, so what is the square root of 50 equal to? That's kind of like the idea here. We want to come up with like equivalent statements to this. 2,500. So that's if we square, but we're not trying to square 50. We're trying to find the square root. So we're trying to find what number. Well, it's not a perfect square, is it? So if I go to my calculator here, if I type in like the square root of 50, I get this decimal. And so we could say, not wrongly, right? We could say that the square root of 50 equals 7 point, we'll say like 0.71, okay? Oh, on your calculator there, so it's a second button, and then it's right there, if you can see it, the x squared, second x squared, get you the square root command. Okay? Actually, does anyone else know there's an exponent we can raise something to take the square root? So like we can do square root 50, but it's also 50 to the...
Can't you do 50 and then a little arrow and then 2?
Yeah, not to the 2. 50 to the 1/2 is the same thing as square root of 50. 50 to the 2, that's squaring 50. That's 50 times 50. Square root of 50, all right, is the same thing as 50 to the 0.5 or to 50 to the 1/2. Same idea, but you don't need to worry about that for right now, okay? But that's the idea for that, okay? So square root of 50. We could say that. Now here's the problem. Is square root of 50 exactly equal to 7.071? No. What did I do to get this number? I typed it in my calculator, but what did I have to do with this number then? I rounded it, didn't I? Like around it. Yeah, question, Ryan? Yes. Yes. Good. And so that's what I'm hoping, but I just want to show it to you again. I just want to show you. So sometimes, guys, this will be sufficient, okay? If your directions say, round your answer to the nearest decimal place, nearest 3 decimal places or something like that, this is okay to say this sometimes. But sometimes we just want to simplify square roots. And in fact, unless you see, give a decimal answer, in general, we don't want to do it this way. Instead, we want to do it another way here. So we're going to take the square root of 50. Okay? I'm going to look at 50, and I can say, all right, square root of 50, that's equal to the square root of 5 times the square root of 10, for example.
How do you know that?
Well, how do I know that? 5 times 10 is 50, right? That's it. 5 times 10 is 50. I just broke it up. Now, is it helpful for me to break up 50 into the square root of 5 and the square root of 10?
No.
Right, because is 5 a perfect square? Is 10 a perfect square? So it doesn't really help me, does it? So I don't want to do it that way. So what else could we say instead? One second, I'll get you. Yeah.
Square root of 7 and square root of 8.
So 7 and 8, they don't multiply to make 50. So we need to come up with two numbers that multiply to make 50.
25 and 2.
Yeah, so there you go. So 25, square root of 50 is equal to the square root of 25 times the square root of 2. Now, this is helpful because we can find the square root of 25. What's the square root of 25? It's 5. So we can say 5 times the square root of 2.
Isn't it 0?
The square root of 25 is 0?
Yeah.
How'd you get that?
Well, I put in my little check mark, and then...
Like this?
Yeah.
Okay. You hit enter?
Then I got 5.
Okay, yeah. It should be 5. Should be 5.
So, where are you getting these numbers from, though? Like, these random numbers?
So the 50, it's a matter of looking at right, how do we do this? Well, the idea, first of all, the overall goal is we want to break 50 up into any perfect squares that we can, that divide it evenly. So, for example, 50 was divisible by 5 and 10. Like 5 times 10 gives you 50, right?
Yeah, like I get that, but like, why doesn't 5 and 10 work? How do you know it's not a perfect square?
So, how do you know 5 and 10 are not perfect squares?
Yeah.
Okay. So, if you look at our list up there on the board, 5 and 10 as perfect squares do not appear, right? We go from 1, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square. So, for example, if 5 is between these two, it's not a perfect square. And then 10 is between 9 and 16, again, not a perfect square. Okay? So we want to, go ahead, sorry.
So if it was 4 and 10, then it would work?
Okay, so right, for example, 40, if the number was 40, you could break 40 down into 4 times 10.
No, but that doesn't work though, because 10 isn't a perfect square.
Well, but if you look here, neither is 2. So you won't always find, not everything will be a perfect square, but in this case, since we're able to simplify it a little bit by breaking up the 50 into 25 times 2, this allows us to simplify at least this piece. You're right, we're going to be left over with the root 2.
One perfect square.
Yeah.
And then where'd you get the 5 perfect check mark?
5 times the square root of 2, because the square root of 25, when you simplify that, it is 5. And then it's times the square root of 2, so that's how you write 5 times the square root of 2.
Just write that dot.
You could write a dot there if you wanted to, yep, right there in between. That's fine. Okay. So, let's try another one, okay? Let's try another one. So how about let's simplify, okay, the square root of 18, for example. Okay, so let's try that one now. Simplify the square root of 18. So what you can do then is we go to our calculator, because maybe some of us look at that and we're like, all right, square root of 18, let's just see if it's a perfect square. No, it's not. Womp womp. Okay, you can see it gives us a decimal there.
You can do 4 times 2.
Okay. So we want to we start with our number 18, and we just start looking at our perfect squares up there, and like, okay, let's see if 18 is divisible by 4, one of our perfect squares. Is 18 evenly divisible by 4? No. So we don't want to use 4, so we'll go to the next one. We'll do 18 divided by 9. 2. So 18 is equal, the square root of 18 is equal to the square root of 9 times the square root of 2. You see that? 18 is divisible by 9, so it's 9 times 2. And then when we break it up like that, what's the square root of 9? We know that's 3. So it's 3 times the square root of 2. And that's your final answer. Well, because again, 2 is, what's it divisible by? It's divisible by 2, which is not a perfect square, and 1, which is a perfect square, but it's just going to be all these 1s.
But that doesn't make any sense that you're just picking one. Why can't you pick the other one? Like, because it is divisible, and you would just get 1 and 9. 9 and then square root of 1.
9 and square root of 1.
Because square root of 1 is a perfect square.
Yeah, but it's just going to be 1, so you just multiply by 1.
It's right?
Yeah, I mean, you can pull up, so which one do you, where are you?
I'm saying that I would do 9 square root of 1.
But you can't do that because 9 times 1 doesn't give you 18.
Right, it's got to break up 18. You break up 18 into numbers that multiply to make that 18. So 18, we take the 9 out, leaves us with square root of 9 times the square root of 2, right? Square root of 18 is the same thing as square root of 9 times the square root of 2. It gives us that square root of 18. So you can't just pick any two numbers you want here. It's got to be two numbers that actually multiply to make 18, but you want one of these to be a perfect square as well.
Doing half of 9.
Not half of 9, the square root of 9. Right? Half of 9 is 4.5. Right. And well, it's 4.5, but anyway. Yeah, who got a question?
Can you use a square root of 4 instead of square root of 2? I got the same result.
Use square root of 4. Well, so, but 4 does not divide 18 evenly there.
No, but I have the same result, the same answer.
I'll have to come take a look at that, because I'm not sure. It should.
With both ways, you have the same answer.
I understand, but this should not have worked out that way, so I'll have to come take a look at it and see what's going on there, okay? But I see what you're saying, but it should not have worked out that way with the 4. I'll have to see what you're saying, though, because I'm not sure. Maybe I understand necessarily then, okay? Let's try another one, just to see how we're doing here. All right, so let's try the square root of 80.
Can we try to think for ourselves?
All right, so square root of 80. I mean, so there you go, okay? So that's what we're going to do. okay? So, I'll give everyone a second here, sorry, and then I'll say. So again, think about two numbers that multiply to make 80, okay? You can just use your graphing calculator to kind of guess and check one of these here if you want, okay? So, all right, hold on, sorry, let me give everyone a chance there. I know. Give everyone a chance. Yeah. Okay. So just think about two numbers that multiply. See what perfect squares divide that 80. So what I would suggest you use, Michaela, is maybe just don't guess and check any two numbers. Look at the perfect squares up there and use those as your like candidates. So for example, start with like 4. Does 80 divide by 4?
Is this right?
And it does. So you can break that up into root 4 times root 20 equals root 80.
Okay, so 4 isn't a perfect square root, but 20 isn't, but 4
Correct.
is.
But 4 is. So that's, you can say that's 2 then, once you take the square root of that. Yes, Dave.
Does this work?
Good job, very good. You're on your way, yes. So you can still simplify that a little bit further, actually. That's why I gave this one to you, because we can simplify this one more than once. What you did there was right. Well, it's not 25 times 16.
Well, I know, like, I was going to 5.
Yes, 5. That's right, yes, that's right. Okay. So, but actually, I do want to kind of start. Ryan, can you tell me, how are you able to break this one up? Because I mean, other people did it differently. I want to show you guys Ryan's method here real quick, though, because, so root 80 is equal to what? So the square root of 20 times the square root of 4. So Ryan was just, I'm assuming, did you like kind of just go through these numbers up here? So Ryan was going through the numbers. She started at 4, which is our lowest one, and she's like, aha, 80 does divide by 4 evenly, it gives me 20. And so she's like, all right, so that means root 80 is equal to the square root of 20 times the square root of 4. And so she's right. And then she simplified that. Square root of 4 is 2, and then times the square root of 20. Now, here's the thing. Is that a final answer, though? Jaden, what can we still do here?
You can pick, well, I don't know, I didn't do it.
Okay, so let's hold off here, Jaden. We'll come to yours in a second.
Oh, yeah.
Divided by 2.
So 20 is divisible by 2, but remember, 2 is not a perfect square. 4. If we can take that 2 times the square root of 4 times the square root of 5, right? 20 is square root of 4 times, square root of 20 is square root of 4 times square root of 5. So, sorry?
So why is all that extra stuff there?
What? Oh, because we simplified this right here. The square root of 20 times the square root of 4 becomes 2, right? Square root of 4 is 2, and then times the square root of 20.
Well, I have a question.
And then I'm going to break up this square root of 20 as square root of 4 times the square root of 5. Okay, so yeah, sorry, question?
Why did the square root of 80 equals the square root of 5 times the square root of 16?
Right, and we'll get to that one. We'll get to that one. You'll see you'll end up with the same answer, but I just want to finish with this way because, again, I want to point out. So just because, here's my basic point here, guys, all right? Just because you find a perfect square, you may still have more simplification to do. So what Ryan did when Ryan just did the square root of 20 times the square root of 4, okay, and did 2 times the square root of 20, all right? There was still more here. You still have to check this 20 to see if it's still divisible by more square roots, okay? You can't just stop once you found one perfect square. Sometimes there's more than one, okay? So you got to check to see. So when I, kind of showed Ryan here that the 20 breaks down into square root of 4. Listen up, guys. This is important. What I was showing here was that 20 is equal to 4 times 5. 4 is, again, a perfect square. So that's really then 2 from the original times square root of 4, which is 2, times then the square root of 5. And we can simplify this. What's 2 times 2? 4 square roots of 5. So that's your final answer. All right, hang on. I promise I'll get to you guys. So that's the final answer. Now, there is another way to do this. Yes, Zaria.
I have a question. Does it matter which way you write it, like inside or out? Like if I did 5 on the outside and 4 on the inside?
Of the square root?
Yeah.
Well, it does matter because when we simplified square root of 4, that became 2. Like the square root disappears when you actually do the square root.
I didn't do it that way.
All right, so let's do it that other way then. So the square root of 80, you said was equal to the square root of 16 times the square root of 5, right?
So you put the bigger number in front of them?
It doesn't matter. Did you square root of 5 times the square root of 16?
Yeah.
Okay, so let's do it that way then. So square root of 5 times the square root of 16. Okay? So, square root of 16 is 4. So you can write, like, square root of 5 times 4, like that, but in general, we put the number that's not underneath the square root, we put that in front. So I would rewrite that as 4 times the square root of 5.
divide that 4 by 2?
Why would you divide the 4 by 2? Where do you see it divided by 2? But there is no division by 2 here, it's just square root of 16 gives you 4.
That's what I thought, I was just making
That's
sure.
it, so yeah, you wouldn't divide by 2. So again, you see 2 different ways to do it there, okay? Yes, EK.
Okay, so I did, I did square root of 80 equals square root of 4 times square root of 20.
Yes.
And then I got 2 square root of 20.
Yes,
And
that's right,
then
but not
20
done.
Isn't a perfect square, and you
Correct.
can do that to any of the other answers, even though they're not perfect squares. So that makes no
Right.
sense.
But all the other ones are
And then you did 2 times 4 times 5 for what reason?
So,
Because you could have done 2 times 10.
so you're right, but why didn't I do 2 times 10?
I don't know. I mean 4 and 5, other than 4 isn't a square root. I mean 4 isn't a perfect square.
4 is a perfect square. It's on our list.
I mean 5 is a perfect
Right,
square.
right, but the point is, go ahead, Brianna, if you want, like, you got it, okay. The point is, all right, that we don't just, I mean, yes, you could have said square root of 20 is equal to square root of 2 times the square root of 10. You could have said that, so I'll write that over here on the side. You could have said square root of 20 equals the square root of 2 times the square root of 10. You can see, though, that doesn't help us in simplifying, right? 2 is not a perfect square, not on our list. 10 is not a perfect square, it's not on our list. But, why did I break 20 up into root 4 times root 5?
What if you can't figure out, the 2 numbers
Because
that
they are-
make
Well, so that's why you have your calculator. You guess and check using your perfect squares. You guess and check.
Okay, so after that, that's fine.
So now that I was able to see that square root of 20 was broken up into 4 times 5, then what is the square root of 4? It's 2. So the 2 from the previous square root of 4 is still there, and then the new square root of 4 has another 2, so you multiply. 2 times 2 gives you 4 times the square root of 5. That's it. Okay? Let's do another one.
Oh, wait.
Do that to any of the other answers.
Great question. So why didn't we do that to this one? For example, this one. Why didn't I break it down any further?
Because they're already simplified.
Because 2 can only break down into 2 times 1, and 2 is not a perfect square, and 1 is a perfect square, but it breaks down into 1, so that's not really that
And
helpful.
9 is
Okay.
3, so
Yes.
For that one, I just did the square root of 16.
Yeah, that's
That's
fine.
what I
There's
did.
some,
It was
so like,
easy to do.
you can, yes, there are sometimes, there's more than one way to do this, and that's good. You look for the biggest one that evenly divided 80. That's good, and that helps simplify it. Because again, you can see that 5 doesn't break down any further into any more perfect squares. This is 5 and 1. So basically, once you get down to a prime number, Ikeba, a number like, 2 that doesn't really break down any further, it's just 2 and 1, you kind of know that you're done there. Okay? Or anything that can't be broken down by another perfect square. All right, let's try another one here. Okay, let's try another perfect square. All right. So let's try to simplify. Let's try to simplify 75. 75. Okay. 75. Okay, so again, let me just show you guys the process here to help you out. For those of you that are like completely stuck, okay? You take 75, the number inside the square root there, and just start guessing and checking your perfect squares. I'm going to start at 4. So 75 divided by 4, can we use the 4? No, it gives us a decimal. So now I'm going to do
You already
75
did.
divided by 9.
it's 25.
Okay, 8.333, 75 divided by 9 does not work. So let's try the next perfect square, which is 16. Does not work.
I did 15.
It's 25.
15 is not a perfect square. You gotta be careful. You gotta use only perfect squares there. All right. So yes, then we use the 25, which is 5 squared. Aha! It does work. We got a integer number, right? A nice whole number there. So it's square root of 75. Then we can rewrite as square root of 25 times the square root of 3. Okay. And what is the square root of 25?
5.
It's 5. So we can rewrite the square root of 25 as just 5, and then we leave that square root of 3.
Wouldn't it be square root of 5?
So square root symbol is like an operation. Once you've done the square root now disappears. We've taken the square root of 25. It is 5, so the square root disappears.
So then how come in your other problem you did 2 times 2 and your square root was 4? Why can't you do 5 times 5?
In the earlier one, it's because we pulled out square root of 4 twice. We pulled out one square root of 4 here, leaving a 2. And then we pulled another square root of 4 out of the 20, so that's why there were 2 2's, because we pulled out square root of 4 twice. And so there were 2 2's. One from the first square root of 4, then one from the second square root of 4. Okay? Like here's the first square root of 4, and that goes to that guy. And then here is the second square root of 4, and that went to then that one. And we still had then the 2 from the original square root of 4 that we pulled out. So those 2 multiplied together. Okay, here it was just one, we just pulled 25 out. Square root of 25 is 5. Okay? Alrighty? That's the idea there. Okay, let's try another one. Let me see here. What did I want to do? I had an idea. Okay. So, I don't know. Let's try simplify the square root of 98. Let's try that one. Okay, square root of 98. So again, we just go through here. 98 divided by 4. Doesn't work.
Mr. West,
Yep.
this is what I do. I just look at the number, and if there's a number that ends kind of the same digit, I
Mhm.
just use that number.
Okay, so what would you try here?
Let's see.
I got,
36, you want to try that? Okay, so 36 doesn't quite work. I always like to go from the bottom up, Jaden, because at least you won't miss something. So I'm just going to start. So I did 4. Now I'll do 98 divided by 9. Doesn't work. 98 divided by, let's see here, 25. Oh, I forgot 16. Sorry, 98 divided by 16.
49.
All right, hang on. Yeah, I'm not there yet. So 98 divided by 36. No. 98 divided by 49. Aha, 2. So 98 is the same thing as the square root of 49 times the square root of 2.
Would you leave it that, or do you just
So it's exactly right. It becomes then 7, because you have to take the square root of 49, which is 7, times then the square root of 2 that's left over there. Okay? So that's the answer for it. 7 times the square root of 2. All right? All right. I want to do one more, and then we'll look at the Pythagorean theorem. Okay. Actually, we're going to do one more after this one. That'll be real quick. Okay. So, actually, I think that should be fine. 97. Okay. So now I'm going to look to my calculator. 97 divided by 4. Nope. 97 divided by 9. Nope. Divided by 16. Nope. Divided by 25. Nope. Divided by 36. Nope. Divided by 49. Nope. Divided by, the next one is 64. Should have known that. Nope. 97 divided by 81.
They can't be simplified.
But we still have so many other perfect squares to pick from
Yeah,
here.
but it can't be simplified.
How do we know it can't be simplified here?
because it's gonna keep getting lower.
These numbers are gonna keep getting lower, and we're gonna run out, and eventually it's gonna be bigger than 97. So do I need to check a perfect square that's bigger than 97? Yeah, no, because then we know we're going to have something smaller than 1 there over here. So yeah, once you get like up to 97, and in fact there's even a shorter way to do it. It's really like once you get to, well, anyway, I won't worry about that too much. But basically there is a shorter way to do it. But if you can see that you're going to get bigger than 97, you're basically like, all right, we're done. So this one, the square root of 97 is equal to just the square root of 97. That's how it simplifies, and that's your final answer. It does not simplify any further. Okay? So there it is. So if you can't divide by any perfect squares, it's simplified as much as you can go. So that's good, right? Sometimes you might not even have to simplify it. That's your final answer. All right? All right, we're all good with that? All right, so I have a short little activity for us here. I hope it's short. We'll see.
Hey.
Take one of those, pass it down, please.
This is triangle. Is it 8 triangles?
Oh, no,
Have you?
I'm gonna triangle in the square code.
I got the Google.
Take
Don't
care
cut
of
off the
like
bit.
every other Tuesday morning.
I wish to know you
I get
would.
which school in the slow, which is the special time, they get it everywhere.
You cut my hair, I swear to fucking God.
Doesn't mean you need to do it, you should have it.
You're trying to make me see.
It's not like I do anything.
Would never.
That sounds like a classic. Yeah. I
Okay, folks, so what I'd like to do real quick,
What they try to get you to do.
I want you to cut out
Dumb if you do that shit, yeah.
cut out these 4 triangles here and these 4 triangles here, and then rearrange them so they fit inside this. So these 4 black triangles, these 4 black triangles, rearrange them so they fit inside here. And then do the same thing for this shape right here. Cut out this square, cut out these 4 triangles, and then rearrange them so they fit in there.
Oh, we cut out all the dark triangles.
Yep, cut out all the dark triangles. All right, and this DE is a square, so just be careful about that. But yes, cut along the dotted lines there, and then rearrange them so they fit inside their respective. You can if you want. I would just suggest cutting out the triangles themselves. Save yourself some time.
How do we know what black triangles go with what white triangles?
The one that you cut, the one that you cut out and goes out.
That was a good one.
Yes. Right. So let me just show you again real quick. We're going to cut out these 4 and these 4, and they go with this square, and then this square right here, and these 4 go with this square right here. You're trying to get them. Sorry. What's the triangle? Yes. That's correct. Well, because a special relationship occurs when we have a right triangle and we want to relate their sides.
Mr. Wade, whenever you cut it out, there's another triangle. Please cut that out too.
Leave the triangle ABC alone, or leave triangle DEF alone too.
Oh, I mean, mine had like matched because I had to cut it.
Okay, that's fine. But you're gonna, yeah. Don't cut. Well,
Too late.
Wait, cut what?
just cut the black triangles out. Cut the black
Oh,
triangles,
I just
please.
cut out the square. The black.
Right, but then you can see there's the dotted lines in there that cut it up into triangles, and cut those
I
triangles.
wish I wouldn't have took all these extra classes, because then I could, like, freaking do, in senior year, do freaking CTC and word studies.
No, because people are like, yes, it does. It represents.
I know, right?
Okay, so again, you can see, here are these little triangles, right? You want to rearrange these triangles, they fit inside that square there. Okay, it's like a little puzzle. So all those little triangles, you're going to rearrange them and fit them inside that square.
Mr. Wood.
Yes.
So after
You'll see.
I cut out everything,
Yes.
like that's what it looks like.
Yeah. Mhm.
But we're not supposed to cut these out.
No, don't cut the triangles out. Yep, keep the triangles.
So what am I?
And then rearrange the little piece, the black pieces, inside the white square there.
Just the one mark.
Yeah.
And in senior year, you only need to take like English and like the requirement class is English and math, right?
I think so, yes.
All right.
And like you were saying, if you were trying to go to CTC or something, Kyle, they would have those classes at CTC, I'm pretty sure.
Yeah, because I want to only do like CTC and work study.
Yeah, I
for
think,
senior year.
you'll have, make sure you talk to guidance about that.
That's what I'm.
See if they can, it's possible, but,
I'm gonna do that later on today.
I know they do offer, yes, ma'am.
Next, like, in the, like, first week of December, I won't be here.
The whole first week?
I have to go do stuff, and then they're pulling me in for season.
Yeah,
Okay.
they're doing that to me too.
Okay,
That's everyone.
And she said that I would have to make up all of my work for all the missing days.
right, so, well, I'll still be recording on YouTube and stuff like that, so you can do it that way
But I
if you'd
don't
like.
think that's gonna happen.
Okay, well, I'm not sure how
Wait, so
else
what are we doing
you're
now?
gonna be able to get your work done then.
I just sounds like reflect everything.
I can call you for flex, but that's not, I mean, like, we can try that, yes, but I understand we have other students
This is
too.
a struggle, yo.
Wasn't that funny? It was.
I'm not smart enough to figure. Oh wait, yes I am. I got this.
I think it's way better.
I believe it.
Okay, and so again, once you got your little square and your little triangles cut out, you want to rearrange those things so they fit inside this other square right there. And you can kind of try and like do this, something, I don't know. So there you go. And they do fit. It does work.
Don't tell us how
I won't tell you.
I wanna be able to do it. Sorry, you just do it.
No, no.
Yes.
Are we using all the black, does it matter what
You gotta do
triangles
it.
we use?
Who the fuck are you?
So these
You as your friend.
Like,
That's my friend.
these smaller ones need to match up with the square on the top here.
Oh fuck, I accidentally cut part of it.
Yep, and then the four bigger ones in the square need to go inside this one down the bottom. Yep. And they do fit.
Wait, I need glue or something to glue these down.
Okay.
Amen to that, yo.
I got like tape or, well, it's actually cool activity, we're not gonna like use it that way, but
Oh, no one cares, Mario. If you can do it, then don't do it.
That's fine, just leave it, leave
I'm
it.
just kidding, sorry.
No, I hate stuff like this. The rest of it, do it.
I got it. I already know it. I already know how to do this.
I figured out this one.
Okay, yeah, that looks good. Good look.
Good job.
Wait, is this right?
That's one way to do it? Mm-hmm. Yeah, that looks good. Yeah, that bottom,
I hate arts and crafts.
that bottom one is a little tricky,
Except
but it does good.
Martin, did you already get the first one?
No.
I gotta like.
Weddings are fucking awesome, man.
No, they're not.
So as you can see, it doesn't quite, like, it needs to like be exact, like it'll exactly stay in there.
I wanna do this.
But you can see
Not working.
it. Well, don't try that one, try this one then.
I already tried.
Did you get it?
No. Like,
Try, I think this one's really easy. Try this. I think you'll do a better job. Use these, use only these. Try it again, see if you can do it. I like come look at it, see how you did. Got them both.
If you.
Okay, so we got one person that's got the top and the bottom so far. It's okay, no great.
We got it.
It's all in.
Matt was able to get the top and the bottom.
Matt.
I'll just have the bottom one.
Oh.
I'll get the top.
Wait, so the bottom, we just keep the big square?
It's this, yeah, just keep the big square and the triangle there.
Yeah,
too.
you're right. I'm not smart enough to do this. Just kidding. I can probably do it. I hate how everything moves. It's so annoying.
Oh, I know.
Yeah, it doesn't have to be perfect, I understand, but I mean, it should fit. It should fit inside. I understand things will move on, but it should fit. It should fit.
Are they all like this?
Okay, it should fit.
I think.
Wait, Mr. Wood, what is this gonna hold? What is this one?
You'll see. I don't want to give away the spoiler, but I will tell you, we're talking about solving right triangles using Pythagorean theorem.
Surprisingly, she doesn't ask questions in history. Surprisingly, she doesn't ask questions in history. Yeah.
Block ball.
I already tried that.
You did? Did it work?
Well, that's so difficult.
Did that too?
Right. 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 That's okay. I'm on your senior.
I hate
What?
You can probably do the rest, right?
That's what I was about to do right there.
There's a couple ways to do it. Okay, yeah, good job. Good job. All right, we got some people that got both. All right, I'm seeing more people that got both.
But the triangles aren't big enough.
What's that?
It seems like the triangles aren't big enough.
Oh, you don't use the small ones. You only use the big triangles and the square for this one.
Oh.
So on the big triangles and the square for that.
This don't look hard.
Still work. Some people still work. This one?
I got it, but it looks hot.
And those, all those.
But, and then you're like, no, you probably did.
A little bit. It's pretty
Hold on.
tricky, isn't it? I see Josh still plugging away at it. That's good. I'll show you guys. Don't worry. Keep trying. Keep trying. Garrett's got the right idea there, I
I
think.
got it. It looks nice.
That's good. That's
Well, look, it doesn't fit.
Mine doesn't fit. Why?
Oh, it does.
No, like,
Stuff.
Better.
Yeah.
Shit, do you still have one for now? I know.
Always be a winner.
Hey, Mr. Whittemire, how's this?
So you can't use those small ones, only the big ones.
Well, the
And,
big ones don't fucking work.
The big ones do effing work, okay? I will show you in a second.
Look.
I saw.
Look, you did it. You did it. Look.
Yes, I did.
What does it look like?
It looks like shit.
Watch your language, please.
It's agitating.
I understand. It's okay. I'm okay with agitating you guys.
No.
Look, let's see. How are you supposed to get
You
like
hate
this
arts and
square
crafts.
to fit in here,
Who,
yo?
who hates arts and crafts?
Like, how many of
Really?
these do we have? Do we only have 3 of these?
You should have 4.
Oh, there it is.
Yeah.
Okay, now I got it.
Okay, so hopefully you guys got the top not too difficult, right? Okay, there's like one possible way to do it.
Oh.
Hey, guys, show them how to do it.
All right, so hang on.
Good job, how to do it.
Well, so Matt, well you can tell me what to do here, but here, there's the top filled in. They all just kind of fit in there real nice.
Can they go underneath?
They should not overlap. It should be completely fit.
I did mine differently, but.
That's okay. It still fits? Yeah, there's like one other way I at least can think of. All right, Matt, so how did you do this bottom one here? You want to just come up and do it? All right. Come on up. So this one's a little bit trickier to see. All right, you want to go ahead? I can like hold something here.
I bet you as soon as I see after that, I'll find out.
No, I already did it wrong. There you go. Okay, so the long side of the triangle is then the side of it goes inside like that. Okay.
I think
Has
I
one of the sides of
figured
the
it out.
square.
But I don't have enough fingers.
All right, so then that one, yeah, that's right. All right, that's in there. Yep. And the square goes in the middle. Exactly right. Look at that. Look at that. Perfect space for this little square there to fit right in the middle.
Yeah, see, that's what
Oh, I'm on YouTube. You are on YouTube. Like and subscribe if you like Matt. Okay, so anyway, here we go. There it is, okay? There it is. So now,
I don't have enough.
let's summarize here then what just happened. So if we go back to that first triangle, okay, what kind of triangle are we dealing with here?
Equilateral.
So we don't know if it's equilateral. In fact, it probably won't be.
I got it.
What kind of triangle is this by its angles, guys?
Oh, alright.
It's a right triangle, okay? So, what did we do to those sides of the right triangle? If you look here, right, what did we do? For this,
Oh
I
my
better pull up the
fucking
original
God,
picture here. We took our right triangle here, we took one of the legs, right, this is a leg, remember it's not the hypotenuse, so it's the leg. We took a leg, and then what did we create off the side of this leg? What type of shape is this? It's a square. It's a square that has the length of the leg. Okay? And what about this leg? What do we create off of this leg? What shape? What kind of shape do we create here? Another square. Shh. Listen, guys. And then what did we create off of the hypotenuse here? Another what shape here? It's a square. And then what did we do? We took this leg we took this square here that was made from a leg, so it's leg squared, plus another leg squared, gave us the hypotenuse squared, right? It fit right inside the hypotenuse. Same thing here. We took a leg of our right triangle, made a square off of it, took the other leg from our right triangle, made a square off of it, and we took those pieces and fit it inside this, the hypotenuse, a square off the hypotenuse. So it's, again, leg squared plus leg squared equals hypotenuse squared. Okay? So, what is that? When you take leg squared plus leg squared equals hypotenuse squared, what do we call that? The Pythagorean theorem, okay? So that's what we just saw. We just did the Pythagorean theorem, okay, to these right triangles here. Okay, that's what we did. All right, so let's take a look. Let's go back. You guys have your notes sheet available. All right, we're going to go back to those real quick. Actually, I'm going to stop right there. I'm going to give you guys the assignment because we're going to run out of time. So we'll finish up Pythagorean theorem tomorrow. Okay, but I did want to show you that. Let me come around with the recycling bin and we'll recycle all these little pieces.
What?
Is this all the little pieces?
Yes, all the little pieces too, please.
You gotta throw all this away. Wait, so everything?
We're recycling it. It's not your notes, but the pieces, yes. Thank you.